Good afternoon. In last lecture, I have discussed the cultivation and also the tissue culture. Today we will see, or today we will start the unit number 4. That we will see the designing of aseptic area and laminar airflow or laminar flow equipment. So, okay, first we will see introduction. The good manufacturing practices and the regulations are critical areas for having a good practices for the pharmaceutical industry. Then much care should be taken. Yes, much care should be taken, especially when the manufacturing the sterile drugs and the other biological products using the aseptic process. Using the aseptic processing. Then a critical area is where sterilized drugs containers and closure may be exposed to the external condition. Therefore it must be designed and manufactured to keep the product sterility. Yes, why sterility important? Because a critical area is where sterilized drugs containers and closure may be exposed to the external condition. Therefore it must be designed and manufactured to keep the product sterility. Then why this is? Because of exposed product is vulnerable to contamination. It means it is easier, it may causes contamination. It may also not be sterilized in its immediate container. Therefore the quality of environment in which the aseptic operations are being conducted, it should be controlled and well maintained. The air quality, it should be properly controlled, especially the particle it carries. Then we'll see the designing of aseptic area. While designing the aseptic area, it is desirable to maintain the sterile condition during the place of working or the place of working. So the following points or the few points are to be considered during the designing of aseptic area. Here we can see the flow diagram of aseptic area. In that it shows office, airlock, then compounding area, stock room, then cleanup area, aseptic filling area, then sterilization, then quarantine, packaging and finishing, storage and shipping, and quality control. Here we can see the flow diagram of your aseptic area. There are few points are considered during the designing of aseptic area. First, that is site, then size, then third, windows, then doors, then surface material, then services. In services, first that is ventilation, then electricity, gas supply, then vacuum arrangement and disposal of waste. Then next, furniture. In furniture, that is shake type and fume cupboard type. We will see one by one. First, that is site. These are the few points that are considered during the designing of aseptic area. This is important. First, that is site. An aseptic room in the building, it should be away from stairs, lifts and corridors. Because why it is away from stair, lift and corridors? Because this provide a route by which the airborne microorganism can travel in the building. So what is the reason? Because yes, this provides a route by which the airborne microorganisms can travel in the building. Then the best site is the one where the worker can work undisturbed. The best site is the one where the workers can work undisturbed. There should be one or two rooms along with aseptic room for providing a washing and changing facilities. I am repeating here, aseptic room, it should be away from stair, lift and corridor. Why it is away from this? Because this provide a route by which the airborne microorganism can travel in the building. The best site is the one where the workers can work without any disturbance. And there should be one or two rooms along with aseptic room for providing a washing as well as the changing facilities. Then next, that is size. The proper size of aseptic room, it depend upon the maximum number of peoples which are going to use it. and the walls and the ceiling of the room, it should be reasonable size so that it can be cleaned in routine without any difficulty or without any mistake. It should be cleaned at a routine without any disturbance or without any difficulty. Then next, windows. In order to provide good light in the aseptic room, the glass planes, it should be used in windows. Yes, in windows, in order to provide good light in the aseptic rooms, the glass planes should be used in windows. Then the ventilation should be provided by the laminar airflow system. The next, that is doors. Indoors, doors, the entrance to the aseptic room should be through an airlock with double door about 1 meter apart. And this is necessary to prevent a sudden rush of air when the door is opened. Why this distance is maintained? Because this is necessary to prevent a sudden rush of air when the door is opened. The outdoor is opened only when it is confirmed that inner door, it means which opens into the aseptic area, is closed. Yes, what I'm saying, I'm repeating here, the outer door is open when it is confirmed that is the inner door, it means the which opens into the aseptic room, it is closed. For this purpose, a small window is needed in outer door, and the inner door is opened when the outer door is closed. Then surface materials. The floors, walls and the bench tops of aseptic room, it should be smooth. Then in surface material, the floors, walls and bench top of an aseptic room, it must be smooth, it should be smooth, then resistant to chemicals, and it should be easily cleanable. Then the walls and ceiling, it should be provided with tiles or coated with hard glass paint. It should be provided with tiles or coated with hard glass paint or smooth plaster, or covered with plastic laminated boards. The working tabletop, it should be made of stainless steel or plastic laminate so as to avoid accumulation of dust. Yes, the working tabletop, it should be made up of what? That is stainless steel or the plastic laminate in order to avoid so as to avoid the accumulation of dust. The next, that is services. There are few services, that is ventilation, electricity, gas supply, vacuum arrangement, then disposal of waste, then furniture, and disposal of waste. We will see one by one. First, ventilation. It includes the removal of microorganism, then control of humidity, then control of temperature, and the provision of fresh air. Yes, in ventilation, it includes the removal of microorganisms, then control of humidity, then control of temperature, and the provision of fresh air. Then clean air. The clean air free from microorganism, it can be produced by mechanical filtration or the electrostatic precipitation. Yes, this clean air free from microorganism, it can be produced by mechanical filtration or the electrostatic precipitation. Then second, electricity. So what is need of electricity? The electricity or the electric supply is needed for lighting and functioning of equipment. Yes, what is need of electricity for lighting, then for functioning of equipment, then functioning of machineries. As far as possible, most of controls should be outside the room. It means the main switch of electricity should be outside the room in order to avoid any difficulty. Then gas supply. Then gas supply is needed for burning of burners. Gas cock may be on the walls or at the back of bench. Then vacuum arrangement. It is needed for clarification and the bacterial filtration. Then disposal of waste. In order to control the dust, the such arrangement must be made that majority of the pipe and the fittings get hidden in the walls of the room, or these are properly covered. Yes, I'm repeating here, disposal of waste. In order to control the dust, such arrangement should be made the majority of pipes and the fittings get hidden in the walls of room, or these are properly closed or the covered. Then next, that is furniture. The furniture like working benches, chairs, the trolleys and the screens are used in the aseptic room. Yes, which points are comes under furniture, that is working benches, chairs, trolleys and screens are used in aseptic room. The furniture should be such that there is the least number of undesirable dust retaining cavities. Yes, it is. See here, I am repeating. It is important. The furniture should be such that there is a least number of undesirable dust retaining cavities. The aseptic technique is usually carried out under a screen which is available in two designs. First, that is shake type, and second, fume cupboard type. This is first shake type. This is made up of wood or plastic material. Then the plastic screen are transparent and hence give a good visibility of the content. Moreover, they are light in weight and it can be moved from one place to another place without any difficulty. Then the screen is a box like structure with a glass sloping front. This type of screen has two armholes on the front side through which the worker can introduce his hands for doing a various aseptic techniques, and the UV tubes are fitted inside the screen in order to maintain the sterility inside the cabinet. Then fume cupboard type. This type of screen is used in those cases where the all apparatus or the all equipments are needed in the aseptic work. Yes, fume cupboard type. This type of screen is used in those cases where the all apparatus and the all equipments are needed in the aseptic work. Then the screen are generally made up of wood. Then the design of screen is just like a chemical fume cupboard used in the chemical laboratory. Yes, what I am saying, the designing of this fume cupboard is just like a chemical fume cupboard used in chemical laboratory. So this is all about the designing of aseptic area. Next, that is laminar airflow equipment. Next point, that is laminar airflow equipment. The laminar airflow principle and the laminar airflow system are commonly used in clean rooms. Yes, laminar airflow principle and the laminar airflow system are commonly used in clean room, then positive and negative pressure room, and other sensitive controlled environment. I am repeating here, the laminar airflow principle and the laminar airflow systems are commonly used in clean rooms, then positive and negative pressure rooms, and other sensitive controlled environment. The best way to understand the best way to understand the laminar airflow is to first differentiate between the laminar airflow as a principle and second laminar airflow in use as a system. Then the principle of laminar airflow. The laminar airflow is a process where air is manipulated. Yes, laminar airflow is a process where the air is manipulated to force air to move at the same speed and in the same direction with no or the with no or the minimal crossover of air stream in a given space. Yes, the laminar airflow is a process where the air is manipulated to force air to move at the same speed and in the same direction with no or minimal crossover of air stream in a given space. In laminar airflow, the motion of particle of the fluid is very orderly. The motion of the particle of the fluid is very orderly with particles close to a solid surface moving in a straight line parallel to the surface. And the laminar airflow is a flow regime that characterized by high momentum diffusion and low momentum convection. This is important for MCQ. This laminar airflow is a flow regime characterized by high momentum diffusion and low momentum convection. The laminar airflow stations are built with respect to the type of process being performed. There are times when maintaining a very high level of cleanliness is desired. So, a laminar airflow cabinet or bench may reside inside an existing clean room. Then, other times, the cabinet may be standalone design in a facility without a clean room at a wall. Then, the laminar flow cabinet are typically designed to protect the working area only. They do not offer operators protection and are not suitable for working with biohazards. Then, laminar airflow system. These are mechanical systems manufactured to provide a laminar airflow in a large or the small area. Yes, these are mechanical systems manufactured to provide a laminar airflow in a large or the small area to perform a certain task in an environment of constant non-turbulent airflow. Then the laminar airflow system are usually cabinet based but may be designed to be booth or a workbench or even a room as well. Then some common designs are, first that is vertical laminar flow cabinet, and second that is horizontal laminar flow cabinet. Here we can see the vertical laminar airflow system. In vertical laminar flow setup, the laminar air is directed vertically downwards onto the working area. In the vertical laminar airflow setup, the laminar air is directed vertically downwards onto the working area. The air can leave the working area via holes in the base. Air can leave the working area via holes in the base. Then vertical flow cabinet typically provides more protection for the booth or the cabinet operator because the air can be directed away from the operator. Next part we will see in next lecture, that is advantages, disadvantages and other laminar airflows.